Hello and welcome to Monday's lesson. Today we're going to be talking about ethanol, which is one of the family of alcohols which we learnt about or we touched on last week. But before we do, what I want you to do is just for a little bit of retrieval, I want you to copy and complete these general equations that we learned last week. So carboxylic acid and an alcohol, what does it make? There's a little clue there. There is a plus sign, so it makes two products. Alcohol and oxygen, what does it make? Again, two products. And an alkene plus hydrogen. Now, there's no plus sign for that one, so it is just one product. So pause the video now and complete that. Lovely, so let's go through the answers. So a carboxylic acid and an alcohol makes ester plus water. Alcohol plus oxygen makes carbon dioxide and water, because any reaction with oxygen is an oxidizing reaction, but technically as well combustion. So this is what we've learned. Anything that we've learned where we've added oxygen is actually burning in the presence of oxygen, giving carbon dioxide and water. And finally, an alkene plus hydrogen is an addition reaction where you're adding the hydrogen across that double bond, so you make an alkane. So what we're doing today is we're going to look a little bit more detail about ethanol. So as I've already said, it is one of the family of alcohols and probably the most common one that you will have heard of. But more than just being used in beverages, it's got a couple of other uses that make it really valuable to us. So we're going to just recall how to draw the structural, molecular and displayed formula for it. We're then going to describe the different ways of making it, and then we're going to compare the environmental impact of making ethanol by both of those methods. So firstly then, I want you to think about ethanol. So S, how many carbon atoms would that have? All on the end, what does that mean for the structure? And I want you to write for me just the general chemical formula, so just the elements and the numbers that there are. Then I want you to draw the structural formula, so how is the molecule arranged? So there's an example there, so it shows what order you would write there, you would draw the structure in, and then draw the displayed formula. So that is all the bonds with the little lines, every atom, every bond inside ethanol. Okay, then, so we'll go through the answers. So ethanol is the second alcohol. So it has two carbon atoms. Remember, anything that starts with F has two carbon atoms. So it's C2H5OH. If you have written C2H6O, technically you are correct, but we put it this way to show that we've got the OH on the end, and it helps us to show that it's an alcohol without us having to draw out all the bonds. So the molecular formula then, that's how it's all arranged, but without showing the bonds. We've got a CH3, then a CH2 group, and then OH. So way to check that you are right, you could always do that last after you've drawn the displayed formula, or you could just look at the top and count that you've got the correct amount of carbon and hydrogen and oxygen atoms. So if you've got 2 carbons, 6 hydrogens and an oxygen, chances are you are correct in that molecular formula. So then the bottom one then, the displayed formula, so you draw all the bonds in the CH3, you can attach a CH2 and then an OH, so you should have gotten that. Now don't forget to draw the bond between the oxygen and the hydrogen atom. It's a common mistake that because it's an OH group, people put it as one thing. But if you miss out the bond between the oxygen and the hydrogen, you will miss out on the mark if you were to draw this in an exam. So well done then, we've constructed it, and what we're going to talk about now is the different methods of making it. So let's have a little look. So ethanol, like we said, is an alcohol. We associate with alcohol probably with the drink, you drink alcohol. Now when you are drinking alcohol, you are drinking ethanol, but as we know from last week's lessons, alcohols are a family of compounds. The alcohol is the functional group on this organic compound. So ethanol, like we said, is the second alcohol. It's got 2 carbon atoms, and we can use it as a fuel. It can be burnt to release energy, or we can use it as a solvent or as a feedstock in processes in the chemical industry. So it is really useful to us, and like we said, it's found in alcoholic drinks like whiskey and wine. So there's two ways which you can make alcohol or ethanol. You can ferment plant sugars, or you can react ethene, which comes from crude oil, with steam, so obviously gaseous water. Now, when you make ethanol for alcohol, it has the type of alcohol you make depends on the fruit or the vegetable, whichever plant that you are fermenting. Now, in order to do ethanol for fuel that we use this way, we use simple sugar cane, because it's the sugar that will undergo the fermentation and create the ethanol that we need. And then we can react it with ethene with steam and come up with it that way. So we're going to go through a little bit about each method to show you. I'm going to talk you through each process, and then you're going to have to identify in a little while the advantages and disadvantages of each process. So I want you to listen carefully, and you might want to make some notes on that. So most ethanol is made from renewable resources using plant sugars and plant material. So the majority of what we use, ethanol in biofuels and solvents, comes from sugars in plants. And what happens is the glucose, which you should know is C6H12O6, we know that from biology, it doesn't react, it breaks down, it's fermented by yeast, which is a catalyst, into carbon dioxide and ethanol. So the yeast acts as a catalyst. Now, basically what happens, the enzymes in yeast respire anaerobically, so you don't need oxygen, and they break it down and carbon dioxide is released. Now, the problem with this is you've got to then use distillation to purify the ethanol. You can't just use it in the form that it's in. You've got to purify it by distillation, which requires a lot of energy. So there are environmental implications of that process. So if we can see there, we've got the good thing about this method is that in warmer countries, generally sort of South America, sugarcane farmers get a lot of business and a lot of work for this purpose. They grow the sugarcane and it provides jobs for them. And it's great because it doesn't use crude oil. We know crude oil's running out. So if we can preserve the stock of it in any way we can, that's obviously going to be a benefit. Another good thing about it is that when you're growing the sugar, it's a plant, it takes in carbon dioxide using photosynthesis. But we know that this process releases carbon dioxide, so it can be considered as carbon neutral, because whatever is given out when it undergoes fermentation would be taken in when the plant was growing. So although it releases carbon dioxide in the process of fermentation, that carbon dioxide is taken in, so can be considered carbon neutral. So the yeast, it's a biological catalyst, it's an enzyme. It needs very specific conditions, so it needs warmth but not too hot. So you've got to get those conditions just right for the yeast to work anaerobically and work at their optimum temperature. So as you know from your study of enzymes, if it's too cold, the yeast will slow down and the process will be really slow. If you heat it up too much, the yeast will denature and the reaction will stop anyway. So it must be filtered at the end and then distilled to get the ethanol out of the mixture, which is a lengthy process and uses lots of energy. And another negative is that you've got to wait for the sugarcane to grow. So the whole process is rather lengthy. So if you were to start this from scratch and you didn't have any sugarcane to start off with, you would have to wait for it to grow and then harvest it and then remove the sugar. And so it's a lengthy process. And obviously, the sugar is continuously replaced, that you'd have to grow it again. So it's not as easy as just feeding it a product into a machine. So if we look at the other method then, which is ethanol from ethene. Now once you've got ethene, which is an alkene, and you react it with steam, which is just water, under high pressure in the presence of a catalyst, you can make ethanol as the only product. So we can see from the equation that ethene plus water, it has to be steam under high pressure in the presence of a phosphoric acid catalyst. You get ethanol. So there's only one product, there's nothing wasted. Now, it's a really quick process, but high pressures and high temperatures mean that you've got a cost implication of that, plus it uses lots of energy to create those. So there can be negative environmental impact that way, just purely because you need to heat it up, and generally you use fossil fuels to do that. Anytime you've got high pressure, you need specialist equipment for that as well. So as the only product is ethanol, the reaction is more efficient than the other one, and it's a continuous process. So as long as you've got ethene, you can just keep providing it into the system wherever it's being created, and ethanol will continuously be produced. So you don't need to wait for things to grow. It doesn't need to be a start-stop process. You can just do it continuously, meaning you would get more from this process. So this is just the equation that shows it. It's the ethene plus your water gives you ethanol, 300 degrees C for your temperature, 60 atmospheres for your pressure, phosphoric acid catalyst. And this is one of the examples where you will need to know what catalyst you need. Sometimes you don't, you just need to know it's a catalyst, but this one is specifically a phosphoric acid. So good things about it only makes ethanol. So you've only got that one product, you have no waste product, so it's more efficient. Now, a bad thing is that the ethene comes from crude oil, which is a non-renewable resource. So it's running out. We also need it for a lot of other things. So to do it this way, you're using crude oil that you've got other uses for. Now, when we get our products from crude oil, we know that we've got to put them through fractional distillation, which uses a lot of energy. And even then, you're then left with an alkane. And to get from an alkane to an alkene, you've got to do cracking, which again needs high temperature and high pressure. So again, uses lots of energy. So although no carbon dioxide is given off in the reaction, a lot of carbon dioxide can be given off during the processes just through the use of a lot of energy, which obviously then has a negative impact on the environment. Okay, so, but like we said, it's a continuous process, so you can get more product from it than growing the sugar cane. But it needs high pressure and temperature, which again is costly and needs a lot of energy, which has negative environmental implications to it. So hopefully you've made some notes on that. Go back and go through it again if you've not. So what we're going to do now is we're going to be applying that information for you thinking about what I've said is good, what I've said isn't so good, and you're going to compare these directly. So what I want you to do, this is your task for today's lesson, is I want you to create a table. You might want to use a full page, definitely half a page, because you're going to put 3 or 4 things in each box. Now, going back over what I've just talked about, I want you to basically categorise each of those as an advantage or a disadvantage for each one. We're not going to put it into an exam question, but you could get asked a 6-mark question where you would be asked to evaluate the 2 methods. So compare them, compare the advantages and disadvantages, and then come up with a conclusion about which one's better. Now remember, when you are evaluating and you're saying something's an advantage, you can't just list, oh, this is an advantage. You've got to say why. If it's a disadvantage, again, you've got to say why. So if you're saying it produces carbon dioxide, is that a good thing? Is it a bad thing? Why? So pause it now, fill in the table, and then we'll go through the answers. Okay, so fermentation of glucose then, so we're talking about the sugar cane. If we have a look at the advantages of it, so it provides jobs for farmers, which is obviously good for their economy, keeps them in business. Photosynthesis takes in the carbon dioxide the photosynthesis takes in the carbon dioxide, which then makes it carbon neutral because any carbon dioxide given off is taken in by other plants. So the disadvantages are the sugar takes a long time to grow, which means you're not necessarily going to get as much product in the same amount of time as the other method. And it produces carbon dioxide, which is greenhouse gas, which contributes to the greenhouse effect leading to global warming. So as you can see for that last one, I've gone into detail about why that one is a disadvantage. So rather than just saying, oh, it produces carbon dioxide, I've explained exactly why that's a bad thing. It shows a deeper level of knowledge and was more likely to get you those higher level answers. If you're looking for a level 3 answer in a 6 marker, getting those 5 and 6 marks, that's the kind of thing you've got to put. Don't just list off a load of points. You've got to say why it's an advantage or why it's a disadvantage. So let's look at ethene and steam. So the advantages are there are no waste products. So it's very efficient. You're going to get more for your money. And it's continuous and fast process, which means you can make more in the same amount of time, which would then mean you've got more to use and more to sell. So the disadvantages, it needs ethene, which comes from crude oil, which is a non-renewable resource, so it's running out, it's a problem. The process involved needs lots of energy, which comes from crude oil and releases carbon dioxide and other pollutants, which again contribute to the greenhouse effect. And high temperature and pressure are needed, which again needs lots of energy. Anytime you've got something that requires a lot of energy, generally that energy is going to come from the burning of fossil fuels, which then has that negative impact. So instead of just saying, oh, it needs lots of energy, explain why that is a bad thing. I ran out of space, but I've explained it to you. So make sure you've used a different colour pen to pop in anything you didn't already have in there. And just so that we've put it in a table so it's nice and easy for you to refer back to rather than it being loads and loads of sentences. It's just nice and brief and nice and easy. So that's it for today. You will go on to use this information later in the week, so make sure you've completed the lesson. And our next lesson, we're going to be back looking at polymers.